Welcome back to my channel, everyone. Sri Tips here. I've got a little bit of gold in this container. Here's the numbers. I've calculated that I need 32.8 grams of sterling silver. That's right here. In order to inquart this gold, we're expecting 15.6 grams of pure gold from this yield. So what we're going to do now is take this out on the melt table, and we're going to melt the gold and add the sterling silver to inquart it. Now what we'll do is transfer this inquarted gold into a beaker, and we're going to process it with some sulfuric acid. Here's our inquarted gold. We've now reduced the gold content in this alloy by adding additional silver. So we should be down around 25% pure gold in here and a 75% silver and base metals. What I would normally do at this point is add dilute nitric acid, but instead what we're going to do is try to take the silver and the base metals out of here with concentrated sulfuric acid. This is Ruto professional drain opener. I got it at Ace Hardware. So what we'll do is open this up. I'm going to add some of the sulfuric acid to our inquarted gold. The sulfuric acid will dissolve the silver, it will dissolve the copper, and it will dissolve any zinc that may be in the gold alloy. Here I added about 200 milliliters of concentrated sulfuric acid. Now what we'll do is put this up on the heat, cover it up, and let the sulfuric acid start pulling the silver and the base metals out of our inquarted gold. I'm going to add some heat. We need to get this sulfuric acid real hot in order for it to be able to pull the silver and the base metals out of there. And then once the boil I feel is complete, what I'll do is I'll pour it off into this beaker over here, because the liquid that we have in here will be full of silver and copper. Pour it into this beaker and save it and recover the silver out later. But for right now, I'm going to put this on time lapse, and then I'm going to do multiple sulfuric acid boils to remove all the silver and base metals out of the inquarted gold. Here we're using sulfuric acid instead of nitric acid to pull the silver and the base metals out of the inquarted gold. The sulfuric acid will dissolve the silver, the copper, and the zinc in the karat gold alloy, but it will not dissolve the gold. The gold gets left behind, and then we can recover it out of the beaker once this process is done and refine the gold. We've had this inquarted gold boiling in hot sulfuric acid for about, I don't know when we start this, probably 15 hours. As you can see, the gold It's looking pretty good there. We got all the silver and base metals pulled out of it. I'm going to pour this off carefully. Set this down here and just let this cool off for a few minutes. I've allowed the gold to cool down to ambient temperature. That's what it looks like in the beaker. Looks pretty good. So what we'll do now, this black stuff here, this is where the tongs that I used to manipulate the beaker, the rubber coating on those tongs was so hot that it began to melt. So now what we'll do is add some hydrochloric acid. Let's see, let's go about 200 milliliters, maybe a little more. Now we'll set this up on our heat source over here. We'll cover it up. We'll start adding a little bit of heat now. In keeping with our no nitric acid theme for this refine, what we're going to do is dissolve the gold using some over-the-counter 29% hydrogen peroxide from the hydroponic store. I'm going to add about 250 milliliters into this funnel here. What we'll do is start slowly dripping in some of our 29% hydrogen peroxide down into our reaction. This takes quite a bit of heat in order to be able to do this. So we're just going to start adding drops of hydrogen peroxide and see if we can use that to dissolve our gold. We've expended all the hydrogen peroxide, so we're going to pull this down out of the reaction now. And what we'll do is pour off this liquid. See if we've got anything remaining down in the bottom of our beaker. Here you can see we've got a few pieces of gold undissolved left down in the bottom of our beaker. So now what we'll do, I'm going to add some more. There's our gold, see it? Undissolved pieces. I'm going to add a little bit more hydrochloric acid. Back up on the heat. Let's move this back out of the way. I've added another 150 milliliters or so of hydrogen peroxide to the funnel. So we're going to continue and see if we can get the rest of the gold down in here to dissolve. Start dripping some of the hydrogen peroxide in. I've still got some solids left in there. Not quite sure what that is. But I think what we'll do here is call it. I'm going to pull this down off the heat now. Yeah, there's some solids in there. But I'm not going to pursue it any further. I'm going to add the liquids together into one beaker. Material that's left over. Looks like it might be some gold that passivated, that reacted with the hydrochloric acid, formed a hard crust of silver chloride on the top of the gold or the outside of the gold, and this protected it from the acid. Here's what's left in the filter. It's lots of silver chloride, and with that much silver chloride in there, plus this passivated bit of gold in this beaker, what it means is I did not boil it long enough in the sulfuric acid, and I didn't get all the silver out of there, so that was one error that we made. What we're going to do now is pour this back through the same filter a second time. It's a little bit on the cloudy side. Let's get a stannous test on our solution. Verify that we've got gold in solution. Boom, dark stain means gold in solution. Waiting for our solution to pull through the filter. I'll go ahead and get these crumbs down into this melt dish. Now we're going to take this over, try to melt it out, see what we got.
more status test. Got gold in solution.
Now we're going to use another over-the-counter chemical. Got this at Ace Hardware. I'm going to use this stump out, which is sodium metabisulfite. I'm going to precipitate out the pure gold. Here we go. Add one more spoon of our sodium metabisulfite. Reach in here and give this a stir. Solution on a piece of filter paper. Do a status test. Make sure we got everything dropped out. You can see by that status test, there's no more gold in solution. Rinse this off a couple times with some distilled water. Add some hydrochloric acid to it. We're going to put it up on the heat and boil it for a few minutes. Some hydrochloric acid. Add some hydrochloric acid. Shot of sulfuric acid for lead. I'll set this back up on the heat now. I think we've got everything to dissolve now. We'll reach up here and shut off the flow of hydrogen peroxide. And we're going to get this out of here. So bring it down here and let it cool off. There's a few tiny pieces of gold left in the filter. That's okay, we'll just put that in our paper storage. We're going to cover that later on. Now we're going to transfer our gold solution to a clean beaker. I've got some ferrous sulfate here, also known as iron sulfate, also known as copperas. We're We're going to use this ferrous sulfate. You can see some crystals of it forming down there. I prepared this ahead of time. It's essentially plant food. So what we'll do here is pour some ferrous sulfate right straight into our gold solution over here, and use ferrous sulfate to precipitate out pure gold. Here we go. All the gold has been precipitated. Pour this off into our waste container. Some more hydrochloric acid and boil it one more time. And now I'm going to add some distilled water. Put it back up on the heat. And boil it in distilled water for a few minutes. Here's our pure gold bar that we just refined. It is a beauty. High purity gold. Let's see, we're expecting 15.6 grams. and the actual yield is 12.5. We had this button of metal that I melted right in the middle of the video that didn't dissolve. Let's see what that adds to it. So that gets it a little closer to what it should be, but I have no idea what's in this metal. And what I'll do is I'll just throw this in with my next batch of carrot scrap, and this will conclude the video. No nitric acid, complete refining to high purity. All right, thank you for watching.